Space, a maelstrom of chaos and violence.
Stars gobbling up other stars, black holes eating up entire star systems, galaxies colliding with other galaxies.
The universe is a hostile place.
You are blowing up a star. There's no way to describe that kind of energy.
The hidden mechanism controlling these phenomena, orbits.
If you understand all possible orbits, you understand the dynamics driving the universe.
Orbits hold everything together and tear it all apart.
Extreme orbits mean colliding galaxies, collapsing dust clouds, the very creation of life as well as destruction.
Extreme orbits, masters of life and death in our universe. This is our solar system. 8 planets, more than 150 moons, billions of space rocks, dust and gas, all orbit a single star in a giant whirling disk 10 billion miles across. It's been this way for 4 billion years. Everything moves round in an orderly fashion, serene and stable. But our solar system is unusual. Elsewhere in our universe, orbits are nothing like this. They're unstable, chaotic, even destructive.
Even in the nearby universe, we see incredibly violent examples of orbits. Giant planets that hurtle in toward their stars. We see shock waves of thousands of degrees perpetuate through the atmosphere.
There are planets that dip right over the surfaces of other stars. Huge stars orbiting each other. Multiple orbital systems where there's just chaos and entire objects can be kicked out of the system.
Stars gobbling up other stars, black holes eating up entire star systems, galaxies colliding with other galaxies. That's the norm.
Earth is an oasis of water and warmth. Life flourishes because of how we orbit the sun. Earth's orbit is almost circular. We stay about the same distance from the sun all year round. The temperature here is relatively constant, and Earth's orbit has been stable for the past 4.5 billion years. Without this stability, we would not exist.
To create DNA out of the oceans takes hundreds of millions, perhaps even 1 billion years. And for that stability, you need circular orbits. And so without the stability of the solar system and the Earth's orbit, there's no life on Earth.
We owe everything to Earth's orbit. We get a gentle ride. In an otherwise violent universe, we've hit the orbital jackpot. Yet chaos is never far away. Even within our solar system, there are extreme and violent orbits where life could never survive. Mercury, the closest rock to the sun and the smallest planet in the solar system. Its orbit stretches into an oval shape. At its furthest point, Mercury is 43 million miles from the sun. But at its closest point, it's just 28 million. This close in, it's hot.
800 degrees Fahrenheit, hotter than a baker's oven. Also, because there's very little atmosphere on Mercury, you'd choke. And because there's no air to speak of, the blood in your body would boil and it would burst your skin. You would literally explode on the surface of Mercury.
But the temperature can also fall to 300 degrees below zero, 3 times colder than the coldest place on Earth. Mercury has the most extreme temperature variations of any planet in the solar system. But it's also proof that orbits don't just loop. With each revolution around the sun, Mercury's path shifts. Over thousands of years, the planet follows a daisy pattern. At the other end of the solar system, there's Pluto, 4 billion miles from the sun. The further away an object is, the slower its orbit. Pluto takes 248 years to complete a single loop. And Pluto is an anomaly. Its stretched orbit is on a completely different plane from the major planets, and it creates an amazing spectacle. During most of its orbit, Pluto is a frozen block of ice and rock. But as it gets closer to the sun, summer begins.
When Pluto warms up, the frozen ices on the surface of Pluto, these are water ices, carbon dioxide, even some carbon monoxide, maybe methane ices, they evaporate and you get a fog, and the fog gets thicker, and then you get thick clouds, and suddenly you have an actual atmosphere around Pluto that wasn't there before.
This atmosphere is thickest when Pluto is closest to the sun. But as the planet heads back into deep space, the temperature plummets to 400 degrees below zero. It begins to snow, flakes of frozen nitrogen and methane.
As winter comes, these gases slowly begin to freeze out of the atmosphere. They may rain down in a snow-like way, but gradually they accumulate sort of a glassy, semi-transparent layer, a frozen atmosphere on the surface of Pluto.
After a bitter winter, Pluto drifts closer to the sun, and the 248-year cycle begins again. Extreme changes like these remind us how lucky we are that Earth's orbit is stable and benign. But it's a delicate balance. The smallest change could kill us all. If Earth's orbit were closer to the sun, we would be like our closest neighbor, Venus.
Venus is a pretty good example of what might happen to the Earth if our orbit shifted a little bit in from where we are now. Venus has this hugely thick atmosphere that traps all of the heat, and the surface is close to 900 degrees. If we moved even just a little bit closer to the sun, we would become more like Venus.
Oceans would boil away. Our planet would become a desert. Life would be destroyed. A small shift in the opposite direction, and instead of boiling, we'd freeze.
You would have snowball Earth, the Earth completely encased in ice, and that's only by moving the Earth a fraction of its distance from the sun.
The polar ice caps would expand. Oceans would freeze. A permanent ice age would begin. The smallest shift in Earth's orbit, and we die by fire or ice. Orbits allow life to flourish. But they can also cause chaos. Orbits are even capable of destroying entire stars. Our planet's orbit makes life possible. But most orbits are violent. Space is a cosmic freeway. Nothing stands still. Everything moves around everything else. Thanks to a single force, gravity.
Gravity is the universal force of attraction that spreads throughout the universe itself. It's the force that holds stars together. It's the force that binds the solar system together.
All objects have gravity, so all objects attract each other. The more mass an object has, the stronger its attraction. That's why falling apples are pulled toward Earth. In our solar system, the biggest object is the sun. It's 700 times more massive than all the planets put together. The titanic force of the sun's gravity pulls all the planets inward. But something stops them from falling in. The planets are in constant motion. They fly through space at incredible speed, not directly toward the sun, but sideways, creating a tug of war between the sun's gravity and the planet's speed. When the two balance out, the planet loops round the sun. We call this an orbit.
An orbit is simply the motion, the path of an object around another object due to gravity. So you can have circular orbits, you can have elliptical orbits. Even if I were to take a ball and throw it in the air and catch it, very briefly, that ball is in orbit around the center of the Earth. It's just motion affected by gravity.
Imagine what would happen if the sun had no gravity. The planet's speed would shoot them out into space. On the other hand, if the planets stopped moving, gravity would pull them into the sun. All orbits are a balance between gravity and motion. We like to think the universe runs like clockwork, everything neat and orderly. The planets moving in cosmic harmony. But that's wrong. Orbits can be wild and unpredictable. And the more objects there are, the more unpredictable their orbits become.
Things can get complicated when you have more than two objects all trying to orbit around each other. Then an orbit can actually loop between one object and another. Speeds can get faster and slower. An orbit doesn't have to be just one regular path.
The universe's creativity defies the imagination. Travel out beyond Pluto, halfway to the nearest star, and you find these. Comets, chunks of ice and rock. They float in vast clouds, frozen remnants from the dawn of our solar system. Every so often, one falls towards the sun.
They can start 1 trillion miles out and fall right above the surface of the sun. So when they're really far away, they're hardly moving at all. When they're whipping past the sun, they're moving really, really fast. And so these can be some of the most extreme orbits in the solar system. They can be so elongated, they're almost a straight line.
Comets travel at up to 1 million miles an hour. They're cosmic missiles, guided by gravity and speed. Comets show us how destructive orbits can be. Many plunge into the sun or crash into planets.
If a comet were to hit the Earth, perhaps 5-6 miles across, watch out. It would be a planet buster. It would be an object sufficient to wipe out all life as we know it on the planet.
But most comets miss. They fly in from deep space and out again on million-year orbits. But move beyond our solar system, and orbits become even more violent. Death spirals rip apart entire planets, shred stars, and even tear holes in space. The universe is unimaginably big, so there should be other Earth-like worlds out there. Orbits just like ours. They were wrong.
So now we're on HD 154088.
They were wrong.
So now we're on HD 154088. And there it is. Looks good.
We have discovered hundreds of planets outside our solar system, but they're not like Earth at all. These are strange, alien worlds with unfamiliar orbits.
What we're finding among extrasolar planets is an incredible diversity of these orbital shapes and sizes. Some of the orbits are extremely tight around their host star, the planet going around in just hours or days. So we're seeing interactions and shapes and sizes of orbits that are like nothing we ever imagined.
Some worlds are so hostile, life as we know it would be impossible. This is WASP 18b. It's a hot Jupiter, a class of huge planets that closely orbit their stars. WASP 18b is 50 times closer to its star than we are to the Sun. It's so close, it orbits in less than 1 day.
If you had said, what's the weirdest, least likely orbit you could possibly imagine? I would have said, take something like Jupiter and plop it down right next to a star, 5 million miles away. And it turns out I would be totally wrong. That is an extremely common thing that we see in the universe. In fact, most of the planets that we're discovering around other stars appear to be in orbits like that.
This cosmic duel produces incredibly powerful physical effects. WASP 18b burns at 4,000 degrees. Thermal hurricanes blast across its surface, and both star and planet are distorted by vast gravitational forces, the same forces that cause the tides on Earth.
Everybody is familiar with the idea of tides. In the course of a day, the level of the oceans get higher and then lower. Well, that's from the influence of the sun and the moon, from the influence of orbits, things that are going around us or that we're going around. If you bring things closer together, tides become more extreme. Planets can actually get pulled into different shapes.
WASP 18b was formed in a cold region of space, far away from its star. Over millions of years, it spiraled into its present position. It's locked in a gravitational battle that can only end one way. Less than 1 million years from now, it will be consumed by fire.
The key conclusion you have to draw is when you see the universe today, it won't be that way tomorrow, and it won't be that way the week or the millennium or 1 billion years later because of gravity.
Our search for Earth-like planets reveals a destructive universe, from the deadly, missile-like orbits of comets to the searing paths of hot Jupiters. There are even planets that don't seem to orbit anything at all. Scientists have recently detected tiny fluctuations in the light from distant stars. The only explanation? A massive object between us and them. These rogue planets don't orbit a parent star. They are planetary orphans, all alone in space.
Planets, by definition, go around stars. So, boy, were we shocked to find rogue planets. Rogue planets are a contradiction in terms. Planets without a mother star.
Scientists think every rogue planet did once orbit a star, until gravity hurled them away. New solar systems are chaotic places. Planets tug on each other and dramatically change course. Some planets even spiral out to wander the galaxy alone.
The presence of rogue planets shows us that gravity is not just this attractive force which binds the solar system together, it can also fling entire planets into outer space.
A recent sky survey suggests our galaxy contains more rogue planets than stars. we've discovered orbits we didn't even know were possible. Gravity and motion keep our universe in constant turmoil. Vast orbiting suns cannibalize each other. Violent vortexes distort space itself. And powerful forces flick a star like a spinning top. Gravity causes chaos on an epic scale, hurling planets to their destruction or firing them off into space. But the cosmic roller coaster gets even more extreme. Orbits become so violent, they rip chunks out of stars. This is HM Cancri, a binary star system 16,000 light years from Earth. They're white dwarfs, small but incredibly dense. 1 teaspoon of white dwarf matter can weigh 5 tons. The stars are just 50,000 miles apart, 5 times closer than we are to the moon. They orbit at more than 1 million miles an hour.
We have 2 white dwarfs an infinitesimal distance apart, rotating around each other in 5.5 minutes. This is a world's record for an astronomical body in space.
The forces are immense. Gravity rips superheated gas out of one star and slams it into the other. Scientists believe this orbit is so violent, it warps the fabric of space itself. In the process, the stars lose energy, falling even closer. Eventually, they'll collide, creating a supernova.
A supernova is one of the most violent, energetic events in the universe today. You are blowing up a star. There's no way to describe that kind of energy.
Some supernovae are so powerful, they are second only to the Big Bang itself for energy and sheer power. They are so magnificent, they can outshine an entire galaxy of 200 billion stars.
Supernovas can create one of the weirdest objects in the universe. A pulsar. Pulsars are intensely magnetic stars. They fire out beams of electromagnetic radiation that sweep across space.
There are few things in the universe more dramatic than a pulsar. Imagine a ball about 10 miles across, rotating hundreds of times a second. With a density that's almost unimaginable, 1 cubic centimeter of this material would have as much mass as Mount Everest.
You would feel a gravity that is millions of times what you're feeling sitting on the surface of the Earth. You wouldn't just be crushed flat by this. You would be crushed into a paste that is only a few atoms thick.
Anything that orbits a pulsar too closely risks being torn to shreds. This is the Black Widow pulsar. It rips through our galaxy at 600,000 miles an hour. The shock wave is so vast, our telescopes can't detect it 5,000 light years away. Traveling alongside it, a brown dwarf, bigger than a planet, smaller than a star. The pair are locked in an orbital dance of death.
The Black Widow in some sense is like a vampire, sucking the lifeblood from this brown dwarf star, eating away at its hydrogen and helium fuel.
Radiation blasts the brown dwarf's gases into space. A pulsar just 10 miles wide is destroying an object bigger than Jupiter. Eventually, the brown dwarf will evaporate. A single pulsar has immense destructive power. But two pulsars together can change the shape of the universe. This is the only known double pulsar system in our galaxy. Orbiting at 700,000 miles an hour, their speed and mass make them spin chaotically.
It's incredible to think of the enormous forces gravitationally that these two stars exert on each other, causing the whole geometry, the architecture of the system to change and spin around like a top on the table.
The gravity of the heavier pulsar makes the smaller one wobble erratically. It whips around so violently that the whole star almost tips over, just like a spinning top. It can't last forever. 85 million years from now, the two pulsars will merge to form a vast gravitational abyss. The universe's ultimate monster, a black hole. A black hole, the most extreme object in the universe. At its center, the laws of physics break down. Time comes to an end. Gravity is infinite.
A black hole is a bottomless pit of gravity caused by the death of a star. There is nothing in the universe more mysterious than how black holes work.
If you want to talk about extreme orbits and extreme gravity, you're talking black holes. That is at the top of the list. Nothing has stronger gravity than a black hole. It is the mass of something like the sun or more, compressed down into a ball that's only a couple of miles across.
50 years ago, black holes were dismissed as science fiction, but not anymore.
Now we see them at the center of galaxies, wandering through outer space. Black holes, we now know, are central to the evolution of the universe.
We now think there may be 100 million black holes in our galaxy alone. An encounter with any of them leads to oblivion. This is one of the largest and hottest stars in the universe. It's 20 times more massive than our sun and 10 times hotter. Stars like this never live long. But this one is locked in a diabolic waltz, trapped in the grip of a black hole. The gravity here is so powerful, the star orbits at 500,000 miles an hour. The black hole sucks the star's outer layers into a vast, swirling disk. A disk so hot, it blasts out X-rays 1,000,000 times more powerful than our sun.
This configuration of star orbiting around a black hole is extreme and it's unstable. First of all, the black hole is eating away at the atmosphere of its companion star, but the star itself is unstable. It will one day undergo a supernova and perhaps leave a black hole in its wake. And then we'll have two black holes rotating around each other, one of the rarest sights in the universe.
Eventually, these black holes will merge to create a new, larger monster, and the cycle of destruction will continue. But this black hole is small. Other black holes, take violence to a whole new level. In 2011, astronomers witnessed one of the biggest explosions ever recorded. A flash of radiation brighter than 100 billion suns. A gamma ray burst. It was a spectacular event. The burst came from a supermassive black hole at the center of a distant galaxy. It had been dormant, but something had shocked it back to life.
If you pass by the event horizon, an imaginary sphere surrounding the black hole, that's the point of no return. It's like the ultimate Roche motel. Everything checks in, nothing checks out.
Several stars were orbiting the black hole at a safe distance. Then one of them got too close. The sleeping giant suddenly awoke. Immense gravitational forces stretched the star to its breaking point until finally it was torn apart. Debris swirled round the black hole, heated to millions of degrees. Two giant jets of gamma rays blasted into space at the speed of light.
A black hole has torn a star apart, swallowed up half of the material of the star, and ejected the other half in an event that is among the most violent things we have ever seen in the history of astronomy.
The event was so violent, we saw it from Earth 3 billion light years away. Black holes can suck in planets and rip apart stars. But gravity doesn't always pull things in.
Any high school student knows that gravity sucks. It pulls, it never pushes. But it's actually more complicated. That's true when you just have two objects. But the minute you have more than two objects, strange things can happen, and gravity can actually push you away.
You can get very close to a body, but if you come in at just the right angle and just the right speed, instead of colliding together, one object can slingshot the other one away.
Recently, scientists discovered stars hurtling away from our galaxy at incredible speed. Normal stars don't do this. So what could accelerate a star to hypervelocity? The answer was a surprise.
You can only eject stars at these very, very high velocities, so close to 700, 800, 1,000 kilometers a second. You could only eject these with interactions with the supermassive black hole.
Each hypervelocity star was originally one of a pair of stars orbiting a supermassive black hole. When they got too close, gravity pulled them apart. The black hole catapulted one star out of the galaxy at 2 million miles an hour. Eventually, the other was sucked in and destroyed.
The interesting thing here is that you can get a complete redistribution of stars. So you have stars that are in the center of the galaxy, and suddenly they're ejected out into intergalactic space.
And it's out here in deep space that orbits are at their most powerful, smashing entire galaxies together to create the structure of the universe itself. Across the universe, extreme gravity is a force of destruction. The orbits of planets and stars can be chaotic, unpredictable, and violent. But on a truly cosmic scale, gravity is no longer just a destroyer. It also creates new worlds. These are galaxies, giant spinning clusters of stars, gas, and dust, 100,000 light years across. Galaxies orbit each other in the same way planets orbit stars. Gravity pulls them together. Their speed keeps them apart. But ultimately, gravity always wins. Entire galaxies smash together.
One of the most spectacular events in the universe is when galaxies collide. You're talking about hundreds of billions of stars, 100,000 light years across. Two of these things slamming into each other.
Collisions between orbiting galaxies take place over millions of years. Gravity slowly pulls them together.
And you get these two galaxies that merge like two fluids mixing together, and you get long tidal tails as they pass through each other, but then gravity brings them back together again, and in the end, you get a full-fledged, more mature, larger galaxy than you had originally.
On this intergalactic scale, gravity and motion are no longer destructive forces. Now, they trigger the creation of life itself.
You would think a galactic collision would be incredibly destructive, and in one sense it is, but in another sense it's a very creative force.
Colliding galaxies smash vast gas clouds together. Huge shock waves rip through them, squeezing the gas. Then something amazing happens, the birth of countless stars.
It's incredible to think about two galaxies that gravitationally attract each other and collide. What could be more destructive? But in fact, there's a power of construction in such mergers, because as two galaxies come together, the gases are compressed, and sometimes the gases are compressed so much that you get the birth of stars and the associated planets around those stars. And so in the titanic collision between two galaxies, you can get the birth of stars and planets and perhaps eventually life on those planets.
Sometimes these collisions trigger a chain reaction. Two spiral galaxies in mid-collision, creating stars and planets. But this time, there's a difference. Some of these new stars are massive, unstable, and short-lived. They explode. Each explosion blasts out new shock waves and triggers the birth of even more stars. Astronomers call this a starburst. It's the ultimate example of gravity's creative power.
A starburst galaxy is one that is creating stars at a much higher rate than we usually see in normal galaxies. And so it's amazing that you can have such a beautiful creative process coming out of something so violent and destructive.
Gravity and motion, the two forces that give birth to every new star, also weave together the fabric of the universe itself. Our cosmos is not random. It has structure. The universe is a vast, three-dimensional tapestry. Each of these threads and filaments contains billions of galaxies. It's the scaffolding that holds everything together. The cosmic web.
And we think about scaffolding of a building, it's just sitting there static. But in fact, this scaffolding is quite dynamic and quite amazing because all of the constituents are moving around at very high speeds, crashing into one another. Galaxies, stars, black holes, supernovae, all in this tremendous cosmic dance.
The cosmic web is incomprehensibly vast. Each thread is full of motion. Galaxies form, orbit, and collide. Countless billions in a constant stream. Every filament is a galactic freeway with an endless flow of traffic. each point of light a galaxy. It's rush hour 24/7, and sometimes there's gridlock. Every billion light years, several filaments join to form a knot. Whole clusters collide to form some of the largest structures we know of, superclusters. This is one of them, Able 2744. 5 orbiting galaxy clusters crashed together in the single biggest cosmic pileup ever discovered. Gradually, the 5 clusters merged and fused to form a single giant supercluster 6 million light years across. The incredible power of orbits can literally tie the universe in knots.
Structures in the universe have evolved over billions of years through their orbits and their mutual gravitational attraction, and they've built up into larger and larger structures. And it's all thanks to these same attractive forces that bring them together, but can also tear them apart.
Again and again, we discover orbits dominating the cosmos.
The atom is the basic unit of chemistry. In the same way, the orbit is the basic unit of the universe itself. If you understand all possible orbits, you understand the dynamics driving the universe.
Orbits have created a cosmos full of richness and complexity.
Orbits are changeable, they're chaotic. Things that we never thought were possible are in fact possible.
From the smallest scale to the largest scale, it's the gravitational interactions and collisions that actually make our universe the beautiful place that it is.
And behind it all is a curious paradox.
Extreme orbits mean variations, collisions. That seems very destructive. But also extreme orbits mean colliding galaxies, collapsing dust clouds, the very creation of life as well as destruction.
Orbits are the driving force behind this never-ending cycle of creation and destruction. They're at the very heart of how the universe works.